So welcome to actual exam P1 lecture. This is lecture 3. So this is one variable discrete distribution, part B, part 2. Okay. So in here we will discuss some typical discrete distribution. So the typical distribution we have like binomial distribution, geometry distribution, and negative binomial distribution, and Poisson distribution. So at first we should know the scenario for those distributions. So for binomial distribution, scenario is just like that. We try n times. Each try has two outcomes. Something happen or not happen. So we call success or not a failure, right? So we let x be the number of success in this n trials. So this x can be 0, no success, right? Can be 1 success, can be 2 success, can be n success, right? So this x we say follow binomial distribution. Okay. So let's say so if we try, so here try fixed time n time. If we just keeping try until 1 success, then such a distribution is geometry distribution. So this x can be a number of try to get at least 1 success. If you get a success, you stop. So this x can be 1 first time you success, or you need to try 2 times, or you need to try 3 times, right? Or you need to try infinite time. Okay. So if we keep trying until r success, then the number of try, those things follow negative binomial distribution. So this x should be at least r, right? So r trials, each one you get a success, or r plus 1, right? Or r plus 2, or until infinity, right? Okay. So for Poisson distribution, it's just like how many times that something can happen during a certain time period. So so this x can be 0, like this thing not happen, right? Or happen 1 time, or happen 2 times, or happen infinite time, right? So such a distribution is called Poisson distribution. So at first we should know which distribution in certain cases. Right? For example, like we have such a problem. So at first we should know this follow geometry distribution or Poisson distribution. Okay. Okay. So let's say, so the probabilities for binomial distribution, we say this x can be so among try n times. So this success can be 0, can be 1, can be 2, can be n. So we just need to know the probability for x equal k. So this is k, we say equal 0, like 1 to n. So x equal k means among n trials, we have k time for success. So success happens p, so p happen k time. Then not success is q, so q happen remaining times. So for k success, we can have this k or that k, like suppose that we have try n times. We can happen that is three, this k or zk, right? So how many such ways we say we just need from n positions pick k positions, right? So for those k positions, this thing happens, happen k, right? Then the many other ones not happen, so n minus k. So this is a binomial distribution. So and for binomial distribution, mean is np and variance is npq. So maybe you should remember those. Okay, you can use those results. Okay, so for geometry distribution, we say x equal k means you need to try k times. So this means, so this is k time, and then this means here first this is fail, then last time success p, right? So this probability is q, so k minus 1 times p. Okay, so or we can say like the pq k minus 1. Okay, and the mean is 1 over p, and the variance is q over p squared. So this mean we can understand this like average, on the average how many times you need to try for one success. So let's say suppose p equals 0.1 or 1 over 10. So this is the probability for success is 1 over 10, means among these 10 trials you can get one success, right? So we know this average, you need to try, on the average you need to try 10 times to get one success. Okay, so for negative binomial distribution, we have r success. Keep trying until r successes. So r success is the probability. Let's see. So last one should be success, right? So among those k minus 1, you should have r minus 1 success. So this r minus 1 success can be here, can be there. So we have this. Like from k minus 1, pick r minus 1. Let this r minus p happen r minus 1 time. Then q happen k minus r time, right? And then last one is success p. So we have this formula. So the mean and variance, we can regard this is negative binomial distribution, just r multiply geometry. Yeah, we can remember this. R multiply geometry distribution. So for geometry distribution 1 over p, so here is r over p, right? So variance is q over p squared for geometry. Then here is r time. Okay. So for Poisson distribution, we just remember that happen k time equal mu k over k factorial, say e negative mu. So we can regard this as the formula. So here mu is, what is mu? Mu is average during the given time period. Like suppose like mu is like the average number for 1 week. Then so during the 1 week, how many things will happen? So k k equal 0, nothing happening, or k equal 1, so we can use this formula. So for Poisson distribution, mean and variance same. Okay. So those are 4 important discrete distribution: binomial distribution, geometry distribution, negative binomial, and Poisson distribution. Okay, so now let's check some examples. So for those examples, first thing you should know is this is visual distribution. Okay, so let's say here, suppose 80% this thing happen, the relief. If the medication is given to 10 patients, what is the probability that it is effective in exact 7? So like among 10 people, the receiving people, there's a good thing happen. So this is binomial distribution, right? So here n equal, we just try 10 people, and k equals 7. And this thing happen is 80%, not happen equal 20%, right? So this probability x equals 7, so equal like among 10, we just pick 7 patients. For them, good thing like they recover, this thing happen 7, and thing not a bad thing happens thus. Okay, so here let's say a patient with a heart attack dies is 0.004. So this probability 0.004, this thing can happen. Okay, so not happen is thus, right? So we have 5 patients who suffer a heart attack. What is the probability that all will survive? So, okay, so this thing not happening, like happening this not happening thus. So this means we also can say this is bad thing happen 0 time. Okay, so this equal okay, 5 patients. So each one is bad. So we can say like from 5 to 0, or we just say and all are survive. So survive. So bad thing happen 0 time, not happen, and this time 5. So this actually is just equal. Okay. Okay. So this example is toss a coin repeatedly. So repeatedly, so always continue, just keep trying. So this is just like a geometry distribution. And let x the number of toys to first head. So for find this probability. So first head equal 5. So this means this is a head. So all are tail, right? So tail is half. So half. So this is just half. This is 5 of 4, and tail, the head also half. Okay. So then here x larger than 5. Larger than 5, so can x equal 5 or equal 6. So we can say this is x equal 5. So we find x equal 5 is 1 over 2 5 power. So x equals 6. I think this is 1 over 2 6, right? So this at least 5, so equals this 5 plus, so equals 6. So 6 is at least, the 6 is 6, that's x equals 6, and x equals 7, and x equals until infinity. So this summation equal, we can take 1 over 2 5 other side. So that's equal just 1 plus 1 over 2 plus 1 over 2 square plus. So this summation equal 1 minus 1 over 2, right? Okay. So this equal, let's see, this equal 1 over 2 5. So this 1 over 2 is 2. So this equal 2 6. No, 2, not sorry. I'm sorry. 2 4. So 16. Okay, for this problem, it says it is known that 20% of product are defective. So 20% defective, 80% good. Products are inspected until fourth defective is encountered. So let x be number of inspections to obtain first defective. So we know this x follow geometry distribution, right? We will continue we will keep inspection until the first defective is encountered. So this x, okay. So we say this x follow geometry distribution, okay. And so there's p. So we say p equal what? Is for 20%, right? Okay. So then once we understand this, then this probability is by now easy. X less than 6, larger than 3, so equal x equals 3 and 4 and 5, right? So x equals 3. So x equals 3 is so 3 times the last one, this thing happen 0.2. Then here first one 0.8, 0.8, right? So x equals 3 is just 0.8 square times 0.2, right? So x equals 4 is 0.8 happens 3 times, right? Good. 0.8 actually good. Then the third time, the fourth time, this, and so 0.84.2, right? Yeah. So here we just need some calculation, and here we can maybe take for calculation we can take 0.2 other side, and also 0.8 to other side. So that's equal 1 plus 0.8 plus 0.8 square. Okay. But anyway, this is just a calculation issue. Okay. Okay, so for this problem, this is a competition, a ping pong competition between two players. Okay, so for each game, player A has 0.55 chance to win, B has this so much chance to win. So in each game, the winner get 1 point, while the loser get -1 point. So the key was here. They will keep playing until the winner comes out. So this is geometry distribution, right? They will keep doing these things until something happens. Okay, until the winner is come. So the winner is the one who point become 2. So we did not the game by the winner. So the like this, like A B A A. So means A means 4 games, and A will win. Okay. Okay. So we understand the situation, right? So the question is that in this case, A will win. So we want to find what is the probability that B will win. So B will win is just 1 minus A will win. So A will win or B win C. So at first we say such problem is geometry distribution, right? So find the probability that B will win. So we can list all cases. Like if first game B win, second game B win, so then B win, right? Plus, okay, so first game like B win, then A win, so then there becomes 0, right? Okay, so then B, so B will win, or A B, or there's a case like A B, then B, or A B A B, right? Okay. So we can use this way, list all cases like then find the probabilities here, probability here. So this is we get the geometry sequence. But we find this is not a good way. We can have a simple way. So this simple way is we can consider this. Let them let this probability as P. So P equal thus. At first we determine this. Determine this first one B win, second one B win. Thus, right? So plus. So if there's a case, then we just regard this just we regard this as a start from here, right? So BA, like this case, so BA is 0.45. B win, second one A win, 5. Or A win, then B win. So here multiply 2, right? So we regard this as a starting point. So then we just check what is the probability A will win. So B will win. B will win is P. So from here we can solve this equation, find this P. Okay. Okay. So for geometry distribution, we usually can use this idea. We call this recursive. Like we just regard this as a starting point, right? So like say we cannot determine who is the winner, then continue. We let this point as new starting point. Okay. So this example says a life insurance salesman sells on the average 3 policy per week. So 3 life insurance policy per week. Use Poisson law also. We know this is a Poisson distribution. So here mu is 3, but the time period is 1 week. So we want to find the probability that he will sell some policy. So some policy means this number will larger than 0, right? 1 or 2 or 3 or infinity. So this one we use as 1 minus px equals 0. So what is x probability for x equals 0? So this equal, like we use the formula, okay, mu 0 over 0 factorial is negative mu. Okay, so mu 0 is just 1, so this just equal 1 minus negative 3. Okay, so here's 2 or more policy, but less than 5. So this means we want to find x 2 or more, at least larger than 2, like 2 or more, but less than 5. So this actually is equal p is x equal 2, 3, 4, right? So for x equal 2, so x equal 2 thus equal mu square over 2 factorial, so is negative mu, so plus mu 3 over 3 factorial plus mu 4 factorial. So here, so is negative mu. So we just put mu equals 3. Okay, so there's a calculation we need to calculate here. Okay. Okay, so here we talking about so they assume that there are 5 working days per week. So what is the probability that in a given day he will sell 1 policy? So we want to find thus, right? He will sell 1 policy. So the formula is equal mu 1, so 1 factorial, and is negative mu. So just equal mu is negative mu. But this here, the mu is not equal 3. Mu equal actually 3 divided by 5. So this is a mu for 1 day. So mu equals 3 is for 1 week. So we just plug in this mu, so we can get this probability. Okay. So for this problem, this one already tell us some those things follow Poisson distribution. So like this is parfaits. So can happen 0, can happen 1, right? So mu average 3. So the time period is 20 weeks. So mu equals 3, but the time period is 20 weeks. So we want to calculate the probability that there will not be more than 1 failure. Not be more than 1 is x less than 1, right? But here we talking about a week, 1 week, a particular week. So, but anyway, so here this equal x equals 0 and x equal 1, right? So x equals 0, use this formula is just equal e negative mu plus x equal 1 is just mu e negative mu. Okay. So only thing we should be careful if we want to find this is what is this mu. So this 3 is for 20 weeks. So 1 week is just 3 over 20. Okay, so we just put the mu is this number, so we can find this probability. Okay, so this is for typical discrete distribution. Like we have a binomial distribution, a geometry distribution, and a negative binomial distribution. So negative binomial distribution is just like R-time geometry distribution. We keep doing until R success. And then we have a Poisson distribution. So for Poisson distribution, we just need to check the time period. So like in this example, if for 20 weeks, the average 3, then for 1 week is 3 over 20, right? So once we know this, then those kind of problem easy. Okay, so we can stop here and